Good morning, class. This is Mr. Eggleston, and this is lesson 6.8, Radicals and Rational Exponents. And this is for Algebra 1. Basically, whenever you see the word rational in math, in algebra specifically, rational means fractions. A rational number is any number that can be written as a ratio of two integers. For example, 1/2 is a rational number. So is 5, because 5 is 5 over 1. So is 2/3, or negative 2/3. They're all rational numbers. So when they talk about rational functions, or in this case, rational exponents, they're talking about exponents that are fractions. Are specifically fractions. All right? So, yeah, this is your favorite kind of number, fractions, which I know is not your favorite kind of number. All right, so the idea is the first learning target is to understand that the properties of exponents extend to rational exponents, rational, fractional, or fractions, and use their properties to identify equivalent expressions. Know that a radical is in simplest form if the radicand, new words, has no perfect square factors involved inside of it. Okay. And simply radicals. Okay. I think that's a typo. Perfect square factors, simply radicals. Okay. Explain why expressions involving radicals can be written with rational exponents and vice versa. Okay, first of all, understand that the properties of exponents, that is, we know the square root of 4 equals 2. So if we square the square root of 4, which means we square 2, we get this equal to 4. So what that tells you is that the square root function is the inverse of the squared function. Okay. Likewise, okay. Likewise, if we have 2 squared, and we take the square root of that, that equals 2. And so you can go either way. Either you square a square root, or you take the square root of a squared. They kill each other and just gives you what's inside. All right, so here, the square root and the squared, they kill each other, and you're left with 2. They are inverse functions. That's the definition of an inverse function, is that they undo each other. Inverse functions. Okay? That's key to understand. Now, they ask you to evaluate each of the following. So pause and do this. Okay. Square root of 16 is 4. Square root of 16 squared is, well, we know the square root of 16 is 4, so that's 4 squared. That equals 16. Notice it's just what's inside the radical. Now they got this weird 16 to the 1/2 power squared. Now remember, properties of exponents. When you raise a power to a power, you multiply the exponent. So 16 to the 1/2 squared is 16 to the 1/2 times 2, which equals 16. Specifically, 16 to the first power. But to the first power is just, you don't have to write it if it's in the exponent. All right? And likewise, 16 squared to the 1/2 power, you multiply exponents, so that's 16 squared times 1/2. That also is 16 to the first. Okay? So, a couple things. What is the relationship between the square root of x and x to the 1/2 power? They are equivalent. They mean the same thing. So if I ask you what the square root of 25 is, if I write it like this, most of you, if not all of you, would say that's equal to 5. But if I ask you what 25 to the 1/2 power is, well, you'd have to, you aren't used to seeing it written like this, but 25 to the 1/2 power, knowing that 25 is 5 squared, that's 5 squared to the 1/2, equals 5. Notice it gives you the same output. So that's how you know that square root of 25, that they are equivalent. Okay, so square root of x is the same thing as x to the 1/2 power. All right? Now it's asking to evaluate each of the following. 8 to the 3rd times 1/3 power. Okay? Multiplying, the 3's cancel out, and that just leaves you with 8 to the 1st. On this case, 8 to the 1/3 cubed is 8 to the 1/3 power times 3 is 8. Okay? I hope you're starting to see a trend here. The cube root of 8 cubed, well, you should know that the cube root of 8 is 2. Why? Because 2 to the 3rd power is equal to 8. So this is the cube root of 2 to the 3rd raised to the 3rd power. The root and the exponent kill each other. So they kill each other and leaves you with 2 to the 3rd, which equals 8. So you see, raising a cube root to the 3rd power, they are opposites, they are inverses. They undo each other and just gives you what's inside the radical. By the way, 8's inside the radical. They call that the radicand. Okay? So what's the cube root of 8 to the 3rd? Well, 8 to the 3rd, the cube root, 8 to the 3rd is 8 times 8 times 8. So if we're taking the cube root, that just leaves you with the 1/8. And it's 8. So what is the relationship between the cube root of x and x to the 1/3 power? They are equivalent. They mean the same thing. Now, we're not going to do this during the video. We're going to do it in class, but not during the video. All right? Now, and we'll do a few examples of example 6. Do the square root of 12 or is equivalent or equals, is the square root of 12 equal 2 times 3 to the 1/2 power? Well, to think about this, you have to remember that this is predicated on the idea that when you have a product on the inside of a radical, you can take the square root of each of the factors. That's a true statement. So when you have the square root of 12, you have to remember 12 is 4 times 3. So this becomes the square root of 4 times the square root of 3. The square root of 4 is 2, so that's 2 square roots of 3. And we just learned that the square root function is the same thing as saying to the 1/2 power. So do they belong in the same flock? Means are they the same? Yes. They simplify to the same expression. Okay. I want to encourage you to do the IXLs on this because you got to get used to this. So, if you're simplifying square roots. Rewrite with different square factors, then simplify. All right? So let's go down and let's say I gave you this. What is the square root of, let's see, 128. You have to think about that. 128 is the same thing as saying 64 times 2. So it's the square root of 64 times the square root of 2. And yes, you should recognize that the square root of 64, that 64 is a perfect square, and that's the number 8. And you have 8 times the square root of 2. All right, so you see, that's how you simplify square roots when it's not a perfect square on the inside of the square root, what we call the radicand. Again, the inside is the radicand. When you see a square root, it'll be the square root. What's underneath is called, in math language, the radicand. All right? So we break the radicand down, and we call this simplified. That's how you simplify a square root. Okay? Now, let's simplify another square root. Let's say 98. Square root of 98. And let's add x to the 6th power. All right? Well, 98 can be thought of as the product of two numbers, so I'm going to break this up. Okay? 98 is 49 times 2. X to the 6th is x to the 3rd squared, because you multiply the exponents. All right? And so the square root of 49 times the square root of 2 times the square root of x to the 3rd squared. Square root of 49 is 7. Square root of 2 can't be simplified. And this right here, they kill each other, right? The square root and the squared. So it just gives you x to the 3rd. Okay. Another way of thinking of x to the 6th is x to the 6th equals x to the 3rd times x to the 3rd. We have two of them. So the square root kills one of them and leaves you with x to the 3rd. The other way of thinking of it is that the square root is also rational exponents. So you can think of the square root of x to the 6th as x to the 6th raised to the 1/2 power. And then you multiply the exponents, 6 times 1/2. That equals 3. So it's x to the 3rd. There's more than one way to skin a cat, as they say. All right, so let me give you another one just like the other one. So if I gave you the square root of, let's go cube root, of 8, x to the 6th power, y to the 8th. Now this is starting to get a little ugly. Well, we know we can break the radicals up, so that's the cube root of 8 times the cube root of x to the 6th times the cube root of y to the 8th. Now the cube root can be thought of as to the 1/3 power, so this is x to the 6th raised to the 1/3 power. The cube root of 8 is just the number 2. And the cube root of y to the 8th is just y to the 8th raised to the 1/3 power. Multiply the exponents. So we get 2x 6 times 1/3, y 8 times 1/3. All right? 6 times 1/3 is 2, so that goes in evenly. That's x squared. All right? 3 goes into 8 twice with a remainder of 2, right? Because, let's see, 3 twice is 6. Yeah, with a remainder of 2. All right. So y to the second 2 2/3 power is the same thing as saying y squared times y to the 2/3 power. 2/3 power is just the 3 on bottom makes that a cube root. 2 on top makes it y squared. And that is the answer in the fully simplified form. It can be challenging to do these, all right? That's a little bit tricky. I wouldn't necessarily expect you Algebra 1 students to be able to handle that. That's more of a Algebra 2 concept. Another way of looking at it is when you break this up, let me rewrite this. So maybe you might like it this way. I'm just trying to show you different ways. So this was the cube root of 8 x to the 6th y to the 8th. All right, first off, you should know what the cube root of 8 is. Since that's a nice number, that's just the number 2. Then you take each of these exponents, and that's x to the 6/3, y to the 8/3. In other words, we look at this as 8 to the 1/3 power, which is 2. And then this is going to be x to the 6th raised to the 1/3 power, which means we multiply. And this is going to be y to the 8th raised to the 1/3 power. So basically, when you look at this, you take the 3 and the 6, you divide it, that gives you 2, so that goes in evenly. So that's going to be x squared, okay? Then you take the 3 and the 8, and you divide 8 by 3. 3 goes into 8 twice, so that will give you a y squared. But there's a remainder of 2/3, or a remainder of 2. So that'll be times the cube root of y squared. Okay? So again, this is a little bit tricky. So the simplified version of this right there is that. All right? But that might be a little bit involved. So don't stress too much. I don't think they get this ugly. Algebra 2 would deal with this. All right? But not Algebra 1. But I just wanted to show you that how crazy this can get. All right? So let's go back up. And let's look at let's see, do we finish all this? Yes. So here we go. The quick notes. Radicals can be written as rational exponents. Square root of x is the same thing as x to the 1/2. Cube root of x is x to the 1/3. And the bth, which is weird to say it that way, but the bth root of x to the a is x to the a over b. Okay? And then all the rules apply. So simplifying radicals, rewrite values as perfect square factors to simplify. That is the square root of 200 is the square root of 100 times 2, which is the square root of 100 times the square root of 200, and the square root of 100 is 10. So that's how they got 10 square roots of 2. Y, exponent rules. Square root of 200 is 200 to the 1/2 power, which is this. And then we can apply the exponent to both factors, the 100 and the 2. And 100 to the 1/2 power is 10, and that's 2 to the 1/2, and we just rewrite that as the square root of 2. All right? Again, this is insane. This can get very complicated. Okay? Y is the square root of x equal to x to the 1/2. We know the square root of 4 squared equals 4. Because of exponent rules, we know 4 to the 1/2 raised to the second power is 4. Because, you multiply. So you multiply the 2 and the 1/2, and that's just 4 to the 2 over 2, which is 4. So the square root of 4 must be 4 to the 1/2 power. That holds for the cube root, for the 4th root, for the 5th root. Okay, so any of the roots. All right, and that's it on this. I'll create a new video for Check Your Understanding. I hope all is well, and I'll talk to you soon.